Hi everyone, this is going to be a review of all of the chemical math that we have done so far this week in Chem. So just to start us out, I want to review the conversion factors that we have talked about so far. So far we have talked about 3 conversion factors. The first one we talked about was Avogadro's number. So this is where we learned that 1 mole is equal to 6.022 times 10 to the 23rd of either molecules or atom. It just depends on whichever you are counting. This conversion factor allows us to go from moles to molecules or atoms, or from molecules and atoms to moles. So it can be either way. The second conversion factor that we talked about was the mole ratio. The mole ratio is completely based on the molecular formula. For example, H2O, for a mole ratio, we could say that 1 mole of H2O has 2 moles of hydrogen. We could also say that 1 mole of H2O has 1 mole of oxygen. It's completely coming just from that molecular formula. This allows us to go from moles to moles. So if we have moles of H2O, we can go to moles of hydrogen or oxygen, and we can also go the reverse as well. The third type of conversion factor that we took a look at was using molar mass. So this comes from the periodic table. And this is the mass of 1 mole of an atom or molecule. This can take us from moles to mass or from mass to moles. We can combine these 3 conversion factors in any way. We can do 1-step, 2-step, we could even do 3-step problems if we wanted to. So we are going to take a look through some of these examples. Let's go ahead and start here with example 1. Example 1 asks, how many atoms are in 2.5 moles of calcium? First step I always want to do when I get to one of these chemical math problems, I want to identify what I'm starting with and what I need to end with. What's my end goal? So here I'm starting with 2.5 moles of calcium. That's what I'm starting with is moles of calcium. I need to end with atoms of calcium because I want to know how many atoms. So this is my end. So this means I'm going from moles of calcium to atoms of calcium. If I take a look at my conversion factors, if I'm trying to go from moles to atoms, I'm going to be using Avogadro's number. So this means that my conversion factor here is going to be 1 mole of calcium is equal to 6.022 times 10 to the 23rd, Avogadro's number, atoms of calcium. Now I can start my setup. So I'm going to start with my starting value, 2.5 moles of calcium, and I'm going to multiply that by my conversion factor. Important thing here is whatever unit I have right here is the unit I want to have down here because I want to cancel it out. So that means that this is what is going to go on the bottom. And I'm going to put the 6.022 times 10 to the 23rd atoms of calcium on the top because we need to cancel units. Now I'm going to make sure before I do anything else that my units cancel. I have moles of calcium, 1 on the top, 1 on the bottom. I can cancel those out. And I'm left with atoms of calcium, which is what I wanted to end with. Now I can finish out my problem. 2.5 times 6.022 times 10 to the 23rd over 1. And my final unit is going to be atoms of calcium. Remember, you multiply everything on the top and divide by everything on the bottom, and just make sure that the unit you end with is the unit that you wanted to end with according to the problem. Let's take a look at this example 2. Example 2 asks, how many moles is 4.5 times 10 to the 24th atoms of magnesium? So again, first thing I always want to do, identify what I'm starting with and what I am ending with. So here, the value they give me, that is going to be my start. I'm starting with atoms of magnesium. My end is moles of magnesium. That's going to be what I end with. So I'm going from atoms of magnesium to moles of magnesium. This is similar to the last problem. Whenever we're going between atoms, molecules, and moles, we are going to use Avogadro's number. So our conversion factor is going to be that 1 mole of magnesium is equal to 6.022 times 10 to the 23rd atoms of magnesium. So let's go ahead and start our setup. We've identified our conversion, our start, our end. So I'm starting with 4.5 times 10 to the 24th atoms of magnesium. Whatever unit is here is the unit that needs to go down here. So that means this is going to go on the bottom. And then I'm going to put 1 mole magnesium on the top. We stop, check, can we cancel what we need to cancel out? Atom is magnesium, yes, canceled out. And we're left with moles of magnesium, which is what we wanted to end with. Now I'm going to just finish out by multiplying everything on the top and dividing by everything on the bottom. And our final unit will be moles of magnesium. Let's take a look at example 3. It says how many moles of nitrogen are in 5.6 moles of Mg3N2. Let's identify what we are starting and what we are ending with. I'm starting with 5.6 moles of Mg3N2, and I want to end with moles of nitrogen. So here we're going from moles to moles. So this is different than the last two that we did. Now we're going to be using our mole ratio. And this comes from our molecular formula. So let's figure out our mole ratio. Our mole ratio here is going to be that 1 mole of Mg3N2 contains 2 moles of nitrogen. Again, this is just coming from the molecular formula. This 2 right here gives us this information. This is going to be our conversion factor. Now that we know what we're starting with and what we're ending with, we can do our setup. I'm going to start with 5.6 moles of Mg3N2. And I'm going to multiply that by my conversion factor. Same thing as we were just taking a look at, whatever unit is right here has to go down here in order to cancel out. So that means that this has to go on the bottom. And then the other part of our conversion factor is what is going to go on the top. So 2 moles of nitrogen, the other part from our conversion factor is going to go on the top. Let's make sure that we can cancel out what we need to cancel out. Moles of Mg3N2, moles of Mg3N2, cancel out. We are left with moles of nitrogen, which is exactly what we wanted to end with. So now we just have to multiply everything on the top, divide by everything on the bottom, and this will give us our moles of nitrogen. Example 4 says how many moles of copper are in 6 moles of CuCl2. So again, always want to look at what am I starting with. Here I'm starting with 6 moles of CuCl2. And I want to end with moles of copper. So this is similar to the last one, where we are going from moles to moles. If I'm going from moles to moles, I'm automatically going to use a mole ratio. So let's get our mole ratio for this one here. My formula is CuCl2. So 1 mole of CuCl2 And in every 1 mole of CuCl2, I have 2 moles of copper. Again, this is coming straight from the formula. Now that I have my conversion factor, which is my mole ratio, and I have my start and my end, I can go ahead and do my setup. So my start is 6 moles of CuCl2, and I'm going to multiply that by my conversion factor. Whatever this unit is, that is the unit that is going down here, because we want to cancel it out. So I'm going to put 1 mole CuCl2 on the bottom, and then the 2 mole of Cu is going to go on the top. Again, this is just our mole ratio. Let me cancel out my units. I have moles of CuCl2, cancel that out, and I'm left with moles of Cu, which is what I wanted to end with. So I can just end by multiplying everything on the top, dividing by everything on the bottom, and I get 12 moles of copper. Let's take a look at a different type of problem here. How many moles of copper are in 6.5 times 10 to the 24th molecules of CuCl2? Here we are starting with molecules of CuCl2, and we are ending with moles of copper. So starting molecules CuCl2, and we're ending with moles of copper. There is no conversion factor that we can get from molecules of one substance to moles of something else. So this is where we are going to start putting together some of these that we have been doing. I know that if I want to go from molecules of CuCl2 to moles of CuCl2, I can just use Avogadro's number. And then I can go from moles of CuCl2 to moles of copper. And I can do this using a mole ratio. So we are now combining 2 of the conversion factors. We're going to use 2 different conversion factors. And we can do this. We can combine them. As long as our units cancel out in the end, we are good to go. So let me show you how we can do this. So our start here is going to be 6.5 times 10 to the 24th molecules of CuCl2. That was what we were starting with. We're going to use Avogadro's number to get it to moles of CuCl2. Just like we've been doing, whatever is right here has to be down there. I'm going to put 6.022 times 10 to the 23rd molecules of CuCl2. And then on the top, I'm going to put 1 mole of CuCl2. This is Avogadro's number. So now we've gone and we are able to cancel out that unit and we're left with moles of CuCl2. So now we're here. But we need to go one more step. And we need to use a mole ratio to get to moles of copper. Our mole ratio here is going to be actually the same one that we used in this problem up here. Our mole ratio is 2 moles of Cu for every 1 mole of CuCl2. Again, just coming from the chemical formula. We're going to take this mole ratio and put it into our setup. So I'm going to put 1 mole CuCl2 on the bottom, 2 mole copper on the top. Let me check and see if my units cancel. Moles of CuCl2, 1 on the top, 1 on the bottom, and they cancel out. And I'm left with moles of Cu, which is exactly what I wanted to end with. So I went from molecules of CuCl2 to moles using Avogadro's number. Then I used a mole ratio to get me to my end. And then to finish this problem out, I would just multiply everything on the top times 1 times 2, divide by everything on the bottom. Again, I'm not super concerned with you being able to actually put this in your calculator or whatever. I know that you can all do that. And then our final unit would just be moles of copper. So how many atoms of Cl are in 3.6 moles of BeCl2? This is my start, 3.6 moles of BeCl2. This is what I want to end with. So let's plot out where we're going to go. Moles BeCl2. If I need to get to atoms of Cl, I can't just go straight there. First, I'm going to have to go from moles of BeCl2 to moles of Cl. How can I go from moles of one thing to moles of another? So when we're trying to go from moles of BeCl2 to moles of Cl, we can use a mole ratio. This is where we can use our mole ratio. Let's go ahead and get our mole ratio. Our mole ratio is going to be, for every 1 mole of BeCl2, we have 2 moles of Cl. That's going to get us to moles of Cl. Then we need to go from moles of Cl to atoms of Cl. How can we go from moles of something to atoms of that same thing? We can use Avogadro's number here. So we can use our 6.022 times 10 to the 23rd atoms in 1 mole. Now that we know the path and the conversion factors that we are going to use, these are our conversion factors, we can start our setup. So I'm starting with 3.6 moles of BeCl2. First thing we're using is a mole ratio, so we're going to use this. So I'm going to put 1 mole BeCl2 on the bottom, 2 mole Cl on the top. Before I move forwards, I want to make sure that my units cancel. Moles of BeCl2, moles of BeCl2. So now I'm here. Now I need to go to the next step. Now my next conversion factor is going to be Avogadro's number. 1 mole of Cl is equal to 6.022 times 10 to the 23rd atoms Cl. Stop, check, do my units cancel? Moles of Cl, moles of Cl. And I'm left with atoms of Cl, which is where I wanted to end. Last thing you do is always multiply out all that's on the top, divide by everything that's on the bottom. And our final unit will be atoms of Cl. We went from moles of one thing, moles of another, using our mole ratio. Then we went from moles of Cl to atoms of Cl using Avogadro's number. Now let's take a look at an example with our third type of conversion factor, molar mass. So this example says how many moles are in 28 grams of Li2O. So this is going to be what we start with, and we're going to want to end with moles. First things first, we know we're going from grams to moles, so we are going to have to use molar mass. So let's go ahead and calculate our molar mass of Li2O. So the way we're going to get our molar mass is we are going to have to do 2 times the mass of Li plus the mass of oxygen. The reason we have to do 2 times the mass of Li is because there are 2 Li atoms in that molecule. So we're going to do 2 times 6.94, coming right from the periodic table, plus 16. And this is going to give us 29.88 grams per mole. So this is going to be our molar mass. So that means that for every 1 mole of Li2O, it is 29.88 grams. Now that we have our molar mass, we can start doing our setup. So I'm going to start with 28 grams of Li2O. We're going to use our conversion factor, which is here our molar mass. I'm going to put 29.88 grams of Li2O on the bottom and 1 mole of Li2O on the top. Doing it this way, I can cancel out grams of Li2O, and I'm left with moles of Li2O, which is what I wanted to end with. All I have left to do then is to do 28 times 1 divided by 29.88, and this is going to give us 0.94 moles of Li2O.